If you're getting into Python, you've probably worked with lists quite a bit. But what about their less famous cousin, the tuple? Well, today we're going to pull back the curtain on this super important data structure. And I think you'll see why understanding tuples is a huge step in writing cleaner, safer, and just better Python code. So, here's our game plan. We're going to start with the basics. What even is a tuple? Then we'll put them head-to-head against lists to see the differences. After that, we'll get into a really cool feature I call the unpacking superpower. We'll cover a few other handy techniques and then wrap it all up with the big one. When should you actually use a tuple in your own projects? Let's get started. All right, first things first. Before we can do anything cool with them, we have to answer the fundamental question, what is a Python tuple? Okay, so think of the tuple as a container for your data. It's an ordered sequence, which just means the items have a specific position and they stay in that position. But here's the word you really need to remember, immutable. That's the secret sauce. It means once you create a tuple, it's set in stone. You can't change it. And this idea of immutability is everything when it comes to tuples. I like to think of it like a sealed envelope. You can look through the little plastic window and see what's inside, right? But you can't open it to add new things or take anything out. The original contents are protected, and that's exactly what a tuple does for your data. And you know what? Here is the absolute best analogy I've ever heard for this. A list is like your shopping cart. As you walk around the store, you can throw stuff in, take stuff out, change your mind a dozen times. But a tuple, that's the final receipt you get at the checkout. Once it's printed, that's it. The list of items is final and unchangeable. Okay, so now that we have a feel for what a tuple is, let's really nail down the details by putting it right next to a list. Honestly, seeing them side by side like this makes it so much clearer when you should use one over the other. This table just lays it all out, doesn't it? Lists with their square brackets are built for flexibility. They're mutable. Tuples with parentheses are all about stability. They're immutable. And because of that, they're often a bit lighter on memory. But here's a huge one for you. You can use tuples as keys in a dictionary, something you absolutely cannot do with lists. That's a massive advantage in certain situations. Now, there's a rumor you'll hear all the time in the Python world that tuples are just plain faster than lists. And, well, there's a little bit of truth there, but the real story is way more interesting. Let's actually look at the numbers. Whoa, okay, look at that. When you're creating really small collections, the difference is huge. A little 10-item tuple is more than 5 times faster to create than a list of the same size. So what's going on? Well, since Python knows the tuple can never, ever change, it can use some serious optimizations behind the scenes. But check out what happens when we scale up. Once we get to 1,000 elements, that huge speed advantage basically vanishes. They're almost identical. So the idea that tuples are always faster is a bit of a myth. They're a lot faster if you're making tons of tiny objects, but not so much for larger ones. All right, let's move on to one of my absolute favorite things about tuples. It's a feature that makes your code look so much cleaner, so much more elegant. I'm talking about tuple unpacking. Just look at how clean this is. Normally, you might have to do A equals my tuple 0, B equals my tuple 1, and so on. But with unpacking, you can assign every single item from the tuple to its own variable in one single beautiful line. And there you have it. A gets the first value, B gets the second, and C gets the third. It's just so intuitive. This is especially handy when you have a function that needs to return multiple values. You can just return them in a tuple and unpack them instantly. So that's great, but what if you're dealing with a tuple and you don't know exactly how long it is? Well, Python 3 has a fantastic solution for that, extended unpacking. You see that little asterisk in front of rest? That's the magic. It tells Python, hey, grab the first few items and then just scoop up everything else into this one variable. And check out the result. A and B get their values 1 and 2, just like we expect. But rest, it becomes a brand new list containing all the remaining items. This is an absolute game changer when you're processing data and you only care about the first couple of elements. So beyond that awesome unpacking superpower, there are a couple of other techniques that are really good to have in your coding toolkit. They can make your code even more powerful and easier to understand. Let's talk about the named tuple.
This thing is awesome. It really gives you the best of both worlds. You get the unchangeable, lightweight nature of a regular tuple, but you can access its elements with a descriptive name instead of a number index. So instead of trying to remember if the x-coordinate is at p sub 0 or p sub 1, you can just write p.x. It makes your code so much more readable.
And hey, don't forget that tuples behave like other sequences in Python. You can use the plus sign to stick two tuples together, or the asterisk to repeat one. The key thing to remember, of course, is that tuples are immutable. So these operations don't change the original tuples. They always create a brand new one. Okay, we've covered the what and the how, but now for the question that really matters for your day-to-day coding. When should you actually choose to use a tuple instead of a list? Here's a really simple rule of thumb. If you have a collection of data that represents a single thing and that data should never, ever change, you should probably use a tuple. Think about things like geographic coordinates, RGB color values, or a record you just pulled from a database. Using a tuple here is like putting a seatbelt on your data. It prevents you or someone else on your team from accidentally changing it later. And this quote just brings it all home. It's from a programmer who was storing coordinate data in a list, and he accidentally modified it somewhere else in his code, which led to all sorts of bugs. It's a perfect real-world example. The immutability of a tuple isn't just some academic concept. It's a practical safety feature that stops bugs before they happen. So the next time you're starting a new project and you need to store some data together, just ask yourself that simple question we started with. Does this data need to be a flexible, ever-changing shopping cart, or does it need to be a fixed, unchangeable, final receipt? Your answer to that question will tell you everything you need to know about whether to reach for a list or a tuple.